Okay, are you able to see this? Okay.
I should start at S. Let's say we're at S and
So for functions,
S.
functions are usually passed by value. So what happens in functions that are passed by value? Let's say you have a function that adds
That makes sense.
sums up two numbers. So
Literally expanding concepts. And I repeat that for all the other ones. Exactly. You got it. Yeah. Until you reach F.
So this is just an example function. So when you have pass by value, well, what usually happens is when you call the function in the main function. So let's say C out some
that's not your exam.
4 and 3.
Bye-bye.
When this function is being executed, basically 4 and 3 are contained somewhere in the memory. Copies of these are made to the function. So a copy of 4 is made to A and a copy of 3 is made to B. So you're not working directly with these numbers. Actually, a better example would be if I declared int x is equal to 4, y equal to 3. So if I pass x and y into the function sum, we're not working directly with these because by default in C++, functions are passed by value. However, if you wanted to make a function that could change directly values that you declare in the main function, what you can do is create you have to specify that. So let's say, for example, I think a function that swaps the values of two numbers, swaps the values of two variables is like the kind of function that you would want to have that you want to pass by reference because you want to make changes to those variables by swapping their values. So I'll talk about how to implement that kind of thing. So let's say for the swapping function, if you're swapping the values of two variables, you're not actually going to be returning any values because you're making changes directly to the variables. So this would be a void function. And then you want to have a name for your function and specify your parameters. So far, it looks about the same, but for pass by reference, you want to specify that it's passed by reference by adding an ampersand sign after the data type. So the ampersand sign indicates that we're not looking at just the value that's contained in these variables. We're going to be looking at their location in the memory. So here we have, we're swapping two values. You want to declare a temporary variable to hold one of their values. Because if you set A equal to B, you'll lose A's original value. That's why you have to save it in the temporary variable. After you do that, you can then set B equal to temp. So I'll show you what's happening actually when you call this function in the main function. So let's say in the main function you declare two variables, well, two variables, X and Y again. Where X is equal to 4 and Y is equal to 3. And then you call the swap function by just passing the variables in. And then to check if it worked, you might say X space Y. So when you call this, what actually happens when you pass by reference is instead of making a copy of these values, you don't make copies of these values anymore. What you're going to be doing is actually working directly with these variables because you're able to access them directly in the memory. So if I were to follow the execution of this, basically, I have a new variable temp that makes a copy of X because X becomes our A. So 4 is saved in here. And then A becomes equal to B. So B's value is 3. This 4 becomes a 3. And then the B, it becomes equal to temp. So the value 4 is saved to Y. So you would successfully swap their values. So that's like a very basic example of pass by reference. So anytime you want to make direct changes to a variable, and they have to be permanent after you leave the function, you have to include the ampersand sign with the data type. And that'll show that, or that'll tell the compiler that you want to access the locations of these variables directly in the memory. Do you want me to write this out and show you that it works? Like, do you want me to put this in like an online compiler or something? If not, we can move on to the next topic. Okay, oh, okay. And Imran, have you confirmed that it works or? Okay, that's good. So since there aren't a lot of people here, if anyone else has any suggestions on what to go over, anything that doesn't make sense to you guys, just any topics, just feel free to go ahead and say so. I'm gonna clear the whiteboard. So if you wanted to take a screenshot, now's your chance. Otherwise, yep. So next topic, since nobody's volunteering any topics, I guess I could go over string methods. Either string methods or recursion. Your preference. Okay. Then we can go over recursion. So I saw that your professor was going over recursion and also recursion with arrays. But I'll do a kind of simpler example first. Okay. So some of the practice problems that your professor had on his slides. So I'm gonna use one of them. So the concept of recursion is the first thing you want to do is think of what is think of a problem, a version of this problem that is so simple that you don't have to do any you don't have to like make it any smaller. You can come up with a solution immediately. So for the update digits problem, he wanted you to create a function. Oh, actually, let me take a screenshot. Let's see. Oh, I guess I could do this one instead. I'll do the get biggest digit. Actually, where did it go? There it is. Okay. So the get biggest digit example that he had in his slides. So the simplest version of this problem, or if we started, think of like a sample input is like if we started with a number, we passed in an integer 1, 2, 3, 4, 5. So this is too big of a problem to solve immediately, because if we're checking each digit one by one, we have to cut off digits until to make sure that we have checked all of them. But let's say we only just pass in 1. So if we look at this, we can tell immediately that 1 is the biggest digit in that integer. So 1 is a version of this problem that is so small, you can get the answer immediately. So this would be the base case. And to extend it, 1 works. If you just pass in 2, 3, any number that is less than 10, we're assuming or any number that is greater than or equal to 0 or less than 10, we pass in any of these numbers, we can tell immediately what the biggest digit in that integer is. So this would be the base case, is if your number is greater than or equal to 0, or if n is less than 10, then you know that the biggest digit is that number. So you just return n. Otherwise, if we don't have this, we have to think about how we can how we might solve the larger version of the problem by turning it into a smaller problem. So I'm going to go back to the original number I was using. So this is for now, like the original problem we want to solve.
Oh, sorry, I have a question real quick.
Yes, Kais?
Wouldn't it be and instead of or?
So oh yeah, yeah, it would be and. Sorry, I was wrong. Thank you for correcting that for me. Okay. So back to the problem. I guess like this is the big version of the problem that you want to solve. To make sure that you're able to solve it, you want to make sure that you're working with smaller and smaller versions of it until you can get down to this base case. So with digits, typically, if you want to get a smaller version of problem, a smaller version of what's the biggest digit in this number is what's the biggest digit in this portion of that number, and compare it to this number and see if which one was larger. I don't know if that one made sense, but I'll like rephrase it. So we're working with the original number. If we want to reframe this in terms of recursion, the biggest number in this 1, 2, 3, 4, 5 would also be the biggest number in 1, 2, 3, 4, whichever one is the larger between 1, 2, 3, 4, and 5. So to get biggest digit of 1, 2, 3, 4, 5, you could also try to get the biggest digit of 1, 2, 3, 4 and kind of ask, is this larger than 5? And if it is larger than 5, then the biggest digit in 1, 2, 3, 4, 5 would just be whatever comes from this. Otherwise, it would be 5. So if we want to make this a more general recursive call, after the base case, we could write something like this. So if you're not at the base case, what you want to do now is get the biggest digit in the smaller version of the problem. So I'm just going to name that S, and I set that equal to get biggest digit of n divided by 10. So the reason for that is if we do this of 1, 2, 3, 4, we want to first get the number that is the biggest digit in the smaller version of the problem, and then compare it to the 5 that you left out. So after we get it, now we can make the comparison. If S is greater than n mod 10. So n mod 10 is the 5 that you left out in this step. So if S happens to be greater, then we want to return S. Otherwise, we're returning n mod 10. Yeah, so this would be the solution to this recursive problem. So like here is where the recursive call is happening, and the recursive call basically at every time you want to find the biggest digit in a version of the problem that isn't the base case, like let's say GBD 1, 2, 3, you're gonna be comparing that to the digit that you left behind. And every step you're gonna return which one was the largest digit in that step. So the solution to GBD 1, 2, 3 would be the solution to whether GBD 1, 2 is greater than 3, which is not. So you're gonna return 3 here. And then this would be what happens when you get to the base case, is we're gonna be comparing GBD 1 versus a digit that you left behind, which is 2. So you just get 2. And when you get to the base case, GBD 1 will just automatically give you 1. So that just resolves very fast. And then when you have all these solutions from previous, they get kind of like sent up to the earlier recursive calls that you made up until you reach like the original function call that was made, and then you get 5, and that gets returned to where you call it in the main body. I hope that made sense. It's kind of hard to explain recursion, but I don't know.
Instead of
Yes.
instead of 1, 2, 3, 4, 5, can you like just try like a different number? So I guess I could like see how.
Yeah. Okay. I'll basically run through what happens with these with the version of the code that I made, but with like a different number. Let's see. Okay, so 4, 6, 2, 5, 3. So I'll try it with this number. So let's say the original call we made is here. So to solve what the biggest digit in this original number would be, we first have to solve what's the biggest digit in the smaller version of this problem. And then we compare it to 3. But we can't solve this yet because this is still too big for us to solve immediately. So we cut that smaller as well. and then compare it to 5. So it's like a question mark. We're not saying that it's greater than 5. We're just asking, is this greater than 5? And that too, we can't solve until we solve the smaller version of that. And same thing again, we can't solve that until we solve this. But we also can't solve this until we solve GBD4. But luckily, this is the base case. Since this is a base case, our original base case said that if we have a number that's greater than or equal to 0 or less than and less than 10, we just return that number. So this recursive call would just return 4. So now we're comparing, is 4 greater than 6? It's not, so we're gonna return 6 here. Because in our in what we wrote, if s wasn't greater than n mod 10, or if s wasn't greater than n mod 10, we just return n mod 10. So here 6 gets returned. This 6 is the answer to GBD 46. So that means here we're asking now, is 6 greater than 2? It is. So the answer to this would be 6. Or what gets returned here is, because this is true, is that is 6. So that means since this was the answer to GBD 462, this recursive call will finally resolve to a number, which is 6. Same thing here. 6 is greater than 5. So here, since 6 is greater than 5, we return 6 here. And that gets passed up to this function call. So that function call gets resolved to the number 6.
So the code was asking so essentially if GBD, whatever number, is greater than the digit we dropped off, then we just replace that with the number, with 6, with the number.
Yeah, so if the biggest digit in your recursive, the smaller version of problem is greater than the digit you left behind, then you return the recursive call digit, basically.
Oh, okay.
Yeah, so like at every step, you're gonna leave behind the smaller digit. So it might be the digit that came from the recursive call, or it might be the digit that came from the digit you left behind. So at every step, it will check it. So that's how you can that's it's hard to explain recursive problems. So hopefully you understand the strategy that comes with you solving problems this way. Let's see what next. I'm gonna clear these. And then I'm gonna go over how you might go about doing recursive problems with arrays, because I saw your professor also did those. Okay. So let me just pull up an example from his website. But first, I guess, does everyone understand how to pass arrays into functions? I'll just clear this first. So I'll quickly go over how you go about passing an array into a function. So let's say you want to create a function that takes in an array, an integer array. Yeah, an integer array. So to do this, let's say void. It doesn't have to be a void function. I'm just using that for now. fun. To do this, you need the data type of the array. And then to indicate that it's array, you use the square brackets, and then you give it a name. Along with this, when you pass into a function, you also have to pass in the length of the array, because you don't have access to that inside the function usually. So let's say int length is going to contain how large my array is. So let's say, well, I'm not going to write the body of the function, but let's say in the main function, let's say in the main function, when you call this, let's say your array is called int a, well, not int a, I use that, int x, and it's an array of length 5. And to pass this into the function, you would just use the array by just passing in the name of it, because it's already been declared as an array. This part here just tells you that it takes an array, a 1D array, and then you pass in the length of it, which is just 5. So that's how you would declare a function that takes in an array, and also call a function that takes in an array. So with recursive calls that use arrays, similar to just regular recursive functions, you're going to want to work with smaller and smaller versions of that array. So I'm going to use an example for your professor's slides, which is sum array. So this takes in a 1D array, returns the sum of its, oh wait, a 1D integer array. And it returns the sum of its entries. So first thing is we want to now write the title line of the sum array. So it's going to return the sum of its entries. Since they're all integers, is just going to be a data type int. And then we have the name of the function. And then we say it takes in an int array called a. And we also pass in its length. Yeah, so this part doesn't really change. And now let's think about what the base case of this would be. I'm going to draw an example array. Let's say it's of length 4. So this is an array of size 4. But you can see that we can't get the sum of its entries immediately because we have to go through every index in order to do so. So something like this will not look like the base case of this problem. Instead, we can think of like a smaller version of this problem would be, I can then take the sum of this smaller array and then I add it to 3, which is the index of the last the index of the or the last index that we kind of cut out in our smaller version of the problem. And also for this one, a smaller version, but we also can't solve this immediately. Because in order to solve this problem, we first have to find out what the sum of these entries are. So the sum of these entries would be equivalent to a smaller array plus the index that we left behind. And then finally, a smaller version of this would be an array that is of size 1 plus the last index that we left behind. But here, now that we have an array that is just a single index, we can get the sum of these entries very easily because it's just one index. It's just what's contained in index 0 in this array. So now that we've like kind of gone through this, you can see that the base case of this kind of problem would be if the array is of length 1, then the sum of that array is equal to what's contained in this index, which is just A0. So if we want to write this more formally in our code, the first thing that we can check for the base case is if our length, which is the parameter we're using to keep track of the array's length, is just 1, then we can immediately return what's at index 0. Because then the sum of the entries would just be what's contained in that single index. But if we don't have an array that's of length, that's just of length 1, then we want to solve a smaller version of this problem. So what is the thing that we're leaving behind? The thing that we're leaving behind happens to be the number that's contained in the last index of the array. So if we pass in 4 for the length for this array, then the number that's contained in the last index, we can access it by using A3. But if we want to expand this to a more general case, let's say we're now just using length to keep track of the length of the array. To get the last index, since arrays are indexed starting from 0, you would just access it using A length minus 1. And that's true for arrays that are indexed by 0. So now we know that the number that we're leaving behind, we can get it using this. Now let's look at what this is. This is actually just the same array, but instead we're like pushing off, we're just cutting off the last index. So it's like we're telling the we're going to be using the same array. We're just telling the function only look at these entries. So these entries are 0 to 2, or it's also an array of length 3. So if we're going to look at a smaller version of the problem, what we want to do is we can pass in some array. We pass in the original array, and then we pass in just a smaller length. And since so it'd be like the same as like kind of passing in a smaller version of the array, because you're making the length decrease again and again until the length hits 1. So to put this in our function, so if the length isn't just 1, what we can do is return some array, pass in A, and pass in the length minus 1, and add that to A length minus 1. And that should be our whole function for if we're working with an array. Any questions?
Yeah, sorry, one question.
Mm-hmm.
Can you explain it one more time why you add a array length minus 1 to some array?
Because if we're looking at the diagram I drew here, we want to get the sum of this original array. So we're going to try to cut it up into smaller problems first, before we can get the larger one. So a smaller version of it would just be an array of length 3, adding on the number that was saved in the last index that we're ignoring. And we can get this by accessing it kind of directly. So this 3, I put it in a box, but it's not supposed to be in a box. This 3 is just the value that was contained at this index. So this 3 corresponds to a length minus 1. Yeah.
Oh yeah, I see.
Did that? Oh yeah. Okay. I'm gonna clear the board. Unless anyone's like still trying to look at this. Is there anything else you guys want to go over?
Can you go over some string methods also?
No? Okay. Let me think. So strings, I'm gonna work with an example string. So let's say string s is equal to la land here. Okay, so string methods, you usually use them by kind of, you need a reference to the string that you are using them with. Here, my string is s, and then you need the delimiter, which is the dot. And then all string methods need parentheses. So even if you're not passing in any parameters, you still need the parentheses. So one string method is length. This will count how long your string is, including white spaces. So if we look at this, L, A, N, D, space, H, E, R, E, question mark. So if we count all of these up, the length of this, or sorry, the length of this returns 10. So in order to see the value 10, you have to put this in a cout statement because this returns the value 10. So if I write s.length here, s.length here, what you should see when you compile this is 10 should get printed to the screen. So long as you declare string s first. A similar method to length is you also have size. So I think this will give you the same result, which is 10. Other than that, you also have I'll just go over all the string methods first, and then I'll go over like some problems that use them. So s dot find. So let's say I want to search through my string and find whether or not the word here is in there. So in order to do that, I would first say s dot find, and then I pass in the string that I'm looking for. You can pass in the string that you're looking for, but on its own. Or you can also do s dot find here. And then as your second parameter, maybe you want to ignore part of the string. So you want to start at like a certain index instead. You can pass in what index you want to start looking from. So here, for s.find, with my method here, basically it'll search through the string and then find the index where that thing appears, which is 6. So this one, s.find here 5, should return the same result because it's still at index. Oh, not 6, sorry. This is 5. Yeah, this is 5 because these are indexed from 0. I'll just erase this so I don't confuse myself. So with strings, you kind of want to treat them like arrays, character arrays instead. You can index them, things like that. You have a similar method, a string method called s.rfind. So let's say I instead want to find E or E. So rfind will start from the end of the string and go from the back of the string and go forward. So this will find the first occurrence of E starting from the back. So we see here that the first occurrence of it is at 8. If we were to do s.find, regular s.find E, this would just be the first time you see an E going forward, which is at index 6. Okay, I'm running out of room here, so I'm going to erase these. Any questions so far? Okay. Okay. Next is, let's say we have the string, and now we want to change the string and get rid of a portion of it. So we can do s dot erase. And to do this, pass in the index you want to start erasing from. So let's say I want to erase this portion of my string. So then I would have to start at 4. First thing you pass in is the index you start from. The next thing that you pass in is how much you want to erase. So if I start at 4 and I want to erase up to here, the length of this is 5. So this will actually this is not, you can't print this. If you do this by itself, basically string s becomes land. Let's say I want to instead replace part of the string with a different string. So I'm going to still work with land here. So let's say I want to replace this part of string with this. So first thing that I pass in is the index I start from. So this is index 5. No, wait, this is index 6, sorry. And then I have to specify the length of the string that I'm trying to get rid of, which is 3, because there are 3 characters here. And then I pass in the new string that I want to replace it with. So after I run this line, land here would become also land here. Yeah.
Is that another column, or sorry, is that another comma after the 3?
3, yeah, it's a comma. So there are 3 parameters here. Okay. Also, as an aside, a lot of these methods are overloaded methods, which means that you'll have basically the same name for these methods, but you might have different versions of them that work for like a different number of parameters. So for instance, do you remember how find, you could just pass in one in just the target itself, or you could pass in the target and then the index you want to start looking from. So this is an example of an overloaded methods because they both have the same name, but these are actually different methods because they take in a different number or different versions of the parameters, but they perform similar functions. So a lot of these string methods actually will be overloaded. So you could always look at the C++ documentation to see what versions there are of them. I'm just doing the most commonly used ones, I think. All right, next is append. So s.append. So let's say I want to append, I want to take the string land here, and I want to add on to the end of it this, which is a white space and the NO. So append, you're always adding on to the end of the string. So all you need here is just a new string that you're adding in. Yeah. Next is s.insert. So s.insert works similarly to replace, only you're not erasing anything. So here you just need to specify what index you want to insert your new string into. So let's say I want to insert it I want to insert a W here. So the index that I want to start from would be where the white space is. So that would be index 4. And I would just pass in W. I think you can also pass in a character, but that's something you can look up on your own. And then after that, the last method that your professor wrote on his slides was the substring method. So let's say I want to I want to just print out a portion of the string. To do that, I can use the substring method. So one version of this, you just have to pass in the index where your substring starts from. So let's say I just want to get here. I would just pass in this the index 5, and that'll give me the string starting at index 5 up until the last the last character in your string. Another version of this is you can pass in the index you want to start from, and also the length of the substring that you want. So let's say I just want land. I can start from index 0, and I pass in the length that I want, which is 4. And this should give me land. Okay, so those are the common methods you're going to be using. I'm going to work with a practice problem now that uses string methods. Something that I saw is something that you might encounter is changing from lowercase to uppercase. Well, actually, not that. Let me think. Wait, string.
Sorry, quick question.
Yes.
So between insert and substring, are
Uh-huh.
they the same thing? Like, can I use, it doesn't have to be one character, right? Like, it can be multiple characters.
Oh yeah, if you're inserting multiple characters, you're basically inserting a string. You're inserting a string. Insert will change the original string to become the new string that you want, because you're going to insert your string somewhere inside that string. Substring, what you're doing is you're taking your original string and you're gonna get from it part of that string. So that's why for that one you need to print it out, because it'll return you a string value instead. But the insert method changes the original string.
Okay, thank you.
Let's see. So here's a problem you could do is let's say I have a string. I want to count how many words in the string. And let's say my string is string x is equal to string x is equal to I love math. So in order to count words in the string, a thing you want to take note of is how many white spaces. Once you encounter a white space in this sentence, then you know that another word is going to show up. So I can have let me think. Okay. So what I need to do is I need to find where the white space shows up. So let's say so this would be x dot find so this will give me the index of the white space that shows up. So once I have that index, I can then take that index and then basically cut off the first part of the string in order to check more of the string. So let me think. So first I want to start a counter or like start at the front of the string. Sorry, I have to like think about this a bit. So once you find a white space, then you know that there's a word after it. So after I find this index, what I can do is I can change the string. And I can erase the first part of the string up until so if this is index 1 up until the index +1. The reason why I write index +1 is because this is where the length goes. So let's say I have this string instead. Then when I find the index of the white space, that would be at index 4. So since this is at index 4, but we want to erase this part of it, it's always going to be the length of the string that we want to erase is always going to be equal to index +1. I don't think your professor is going to give you anything as hard as this one on the exam, though. This is just an example that I came up with on the spot. So once you erase it, you then want to work now with the smaller version, or like the new x. And basically you want to keep doing this until the length or x dot length is equal to is greater than 0, or x dot find fails. I'm not sure what the dot find method returns when it fails, though. Let me look that up. Okay, I found online that the dot find method doesn't return -1 when it fails. Instead, it returns something else, which is implementation based, which is not something that you have to know on the exam. So I think this problem might not be a good one to start with. I'm gonna change it to something else. Sorry about that. Instead, yeah, and position or something, or But I think that's it's not something they're expected to know on the exam. Yeah. So I might change this to let's do uppercase. Or let's do let's do let's make a program that changes. Oh, thank you. Oh, it's too late now. Changes uppercase to lowercase and lowercase to uppercase. And let's say the string I'm gonna be working with is actually so a thing I'm gonna go over really quickly is characters. So all characters, see the white space, they're represented by a numerical value, which you can look up using the ASCII table. But basically in the ASCII table, all lowercase letters from A to Z are contained in the range 97 to 122. All uppercase letters are contained in the range 65 to 90. These numbers, you don't have to know. There's a way to like remember this so that you don't have to remember the number specifically. Basically, if you convert this or cast any character as an int, you'll get the ASCII value. So a thing you can do instead is if you're trying to find out whether you're whether a character in a string is in the lowercase range, what you can do is so I'm just gonna write something to go through the length of the string. So our string was S, so I have the length of it. If so, like I mentioned, strings are like character arrays. So you can reference, you can get each character of the array using the name of the array and the index that the character is at. So SI is gonna be a character. So I want to know if this is inside this range. I want to know if it's a lowercase letter. So the way I could do that is if I ask if SI is greater than or equal to A. Oh, oops. And if SI is less than or equal to Z, this will still work. And it will still convert this into its corresponding ASCII value. So basically, now if you do this, you don't have to memorize these numbers. So if it's in this range, then we want to convert it to an uppercase letter. So the way you do that is the difference between the lowercase letters and the uppercase letters. If you want to go from lowercase to uppercase, you have to subtract the number. And the number you want to subtract is 32, I believe. Yeah, 32. Because if you can see here, uppercase A is 65. Lowercase a is at 97. So if I want to go from lowercase to uppercase, I have to subtract off 32. So the way I can do that is I can set SI. I set that equal to char SI minus 32. But if you don't want to memorize this number as well, instead of using 32, you can also use the characters directly and say if you're going from uppercase to lowercase or lowercase to uppercase, then you want to add on a minus a. So I changed this to addition because you might not also remember which one was in the which one is represented by the higher ASCII value. Oh, it's sorry, it's I think it's always minus, yeah. So a minus a, and that should change what's at SI to become the uppercase version of that instead. Yeah, okay, yeah. Alternatively, now you want to check if SI is in the uppercase range. So you can do the same thing, which is now you're using uppercase A instead and uppercase Z instead. Same thing, now you want to set SI equal to the casting of SI minus A minus A. So the case that you're in goes first, and the case that you want to go to goes second. So once you have this, once you're done with this for loop, basically every character in this string it'll go through every character in the string, check if it's uppercase or lowercase, and if it's uppercase, it'll convert it to lowercase. If it's lowercase, it'll convert it to uppercase. But if it encounters anything that isn't in that range, like the white space, it'll leave it alone. So this is how you work with cases. Yeah. Any questions? Anything that anyone wants to go over more? Like any specific topics? Because other than that, I'm not exactly sure what more there is to go over.
Are you like familiar with his grading at all or not really?
I've never taken Steinberg's course. Kevin, are you familiar with how he grades? He's shaking his head. He doesn't know either. Did he mention that it was cumulative or?
Yeah, he said because we have to do the learning outcomes. So he said it
Uh-huh.
would be basically the test is on everything. How we
Okay.
learn.
From what I see from how he's teaching the class, it seems like he favors asking you guys to write programs. The programs that you're writing at this level, like towards the end of the course, I think they naturally incorporate a lot of things that you learned from before anyway. So long as you understand like while loops, for loops, how to set those up, how to set up functions, and nested loops, arrays and stuff like that. I don't think you need to review those too much if you already understand those. I think probably since he hasn't tested you on recursion yet, and string methods, there's probably going to be questions on the exam related to those.
Yeah, do you feel like recursion ties into like functions, like setting
Yeah,
up functions?
yeah, because you can't do recursion without writing a function. because it relies on the function call to call smaller versions of itself.
You think you could do like one more practice problem?
Yeah, do you have any suggestions?
Not in particular, but I mean, because I just want like another example on how like recursion, like another way to use recursion. Can I give you a problem? Like, can I give you a practice problem right now? Can I look
Oh
real
yeah,
quick?
you can give me a practice problem.
Okay. I have them saved. Um, uh, oh, maybe with random. Can you use something with random?
So something like generate a random number between X and Y or something like that.
Yeah.
Okay. So
Mm.
for those problems, you need to in your program, you need to include certain libraries, C headers or something. So one that you need is well, there's IOStream. Another one you need is the C standard library. And that'll give you access to the random function, the number that the function that generates a random number. Um, on top of that, a thing that you could also do is include seed time if you want to seed the random function so that you can generate it'll see the function so that when you compile it and run it, every time you run it, you should see that it generates it won't generate the same sequence of random numbers. Int main. Okay, so the first thing that you can do when you're doing something with random numbers is you can seed your function. So srand is a function that lets you seed it. And then you want to use the time function from the ctime library and pass 0 in. If Steinberg didn't teach you this part, you don't have to bother with it. But basically what this does is when you're passing in the time 0 function, this will give you basically how many seconds have passed between I don't remember the exact date, but there's like a certain date that it has. And it'll give you how many seconds have passed between that date and the second that you run the program. So if you're quick enough, it'll give you the same second between your runs, but usually it'll generate a different number because time is passing. Time is always passing.
Yeah, he told us about.
Yeah. So this is useful because if you're doing this, you're basically passing in, you're kind of almost guaranteeing that you're passing in a different number to seed your random function. And when you're seeding it like that, it'll generate a different sequence of random numbers. So once you seed it, what you want to do now is let's say I want to generate a number between 5 and 51 and 104. So I just want to print out a number between these two numbers, including these two numbers. So to do that, what I can do is first the cout statement. And then I have my ran function. So ran will generate a random number. This number could be very large or very small. So, but very likely you're going to generate a number larger than the range that you want. So a thing you can do to, you want to get it within that range. What you can do is try to figure out how many numbers are between these two numbers. So the way you do that is you take the larger number, you subtract off the smaller number, and then you add 1. So what this does is when you subtract off 51 from 104, it's like you're counting how many gaps are between how many gaps that you're jumping over to get to 104. But you want to count the numbers themselves. So you add on 1. Once you have this, how many numbers are in your range, you want to use the mod function or the mod operator to only generate this many numbers. So what this does is, let's say this is 4, 1 gives you, so this will give you 4, 5. So the number that you get in the end is 54. So you're going to be modding by 54. What's the lowest number that you get when you mod by 54? It's 0. What's the highest number you can get when you mod by 54? It's 53. So this is still too small to be here. So what you have to do is you want to get the smallest and the highest number in between to be in your range. So what you can do is any number that ran mod 54 generates, add on 51. So the possibilities that it can generate, when you add on 51, you're guaranteeing that your number stays between 51 and 104. So after you write this part, then you just want to add on the smallest number in your range. And that guarantees basically that when you run this program, you're going to get a random number between 51 and 104. I'll show you also why this works. If you're choosing a random thing within an array, do you just use the array size? Yeah, you would just use the array size. So let's say if you're trying to, well, I'll show you with the array, I guess. Let's say you have an array of size size 5. So the possible indices that you can pick from range from 0 to 4. So now you know that your lowest number is 0. Your highest number that you can possibly pick from is going to be 4. So if I want to generate an index in this range, I want to take the highest number, 4, subtract off the lowest number, 0, and add 1. So that gives you 5. And the reason in this example, it's clearer why this works, because if you look here, even though it starts with 0 and ends with 4, you're looking at 5 indices in total. And when you mod by a number, you always get a range between 0 and that number -1. So if you're trying to get an index in this range, all you need to do is ran by 5, ran mod 5. And this will give you any index from this array. And once you have that index, let's say I saved it in int index, I can then reference, let's say my array is A, I could then reference, I can then print out the element at that index by writing A index. Yeah. But basically, the general formula for this is if you want to generate a number between X and Y, or sorry, where generate a number in the range where min is your minimum number and max is your maximum number. The formula is always rand mod max minus min plus 1. So you want to keep this part in parentheses because when you mod by this number, it'll give you a range between 0 and this number -1, 0 to n. And then when you want to bring it up to the minimum, you want to add min onto that. So this is the general formula you want to use for random numbers. Yeah. Kevin, could you post the feedback form in the chat? Yeah. So so take some. I don't know what else to go over. If you still want to go over anything, just let me know. But if you're take the time to fill out a feedback form because that helps us keep these sessions running. If you've found them helpful. We also do them for other CS courses. Oh yeah, I can go over recursion again. Okay, I'll clear out the whiteboard real quick. So Kevin just posted the feedback form in the chat. If you could take some time to fill that out, we'd really appreciate it. And I'll go over a recursion problem. Let's see. Okay, so this one's a simpler problem. So he had this in his slides. Or rather, never mind. Let's not do that one. That one's too easy. Has 3, where returns true if number has 3 in it. Otherwise returns false. If no 3 is in the number. Okay. So okay, an example. I'm going to use an example argument that might get passed into this function. 4, 5, 7, 2. While you as a person can look at this and see that there is no 3 in it, the computer only can look at it 1 digit at a time. Or at this point where you're at in CS in coding, you only know how to make it look at 1 digit at a time. So that means if I have this problem, I can't solve it immediately because the computer, even if it's looking at this digit currently, it hasn't looked at all these other digits yet. So a smaller version to tackle to make this problem easier for us is we could also look at, since we already know, we're looking at this 3. If this isn't a 3, then now we want to solve the problem for the rest of the digits. So the rest of the digits is just 4, 5, 7. So now it's equivalent to, like, let's say now we want to look at has 3, 4, 5, 7. So this is a smaller version of the problem because we already checked the last digit in the original recursive call that we made, or not recursive, the original function call that we made. We already checked 2. Now we want to check the rest of it. So a smaller version of this problem is this number with the last digit cut off. So that's n divided by 10. So now we want to check the smaller version of this. The answer to this one would be we only have access to the last digit currently. So we check, is this 3? And we can see that it's not 3. So since it's not 3, we can't answer whether the entire thing has 3 in it because we haven't looked at these 2 digits yet. So now we want to call it with a smaller version of that problem. 45. So just like with the previous recursive calls that we made, we only have access to the last digit. We want to look at it and go, is this 3? It's not 3. So we want to look also at the rest of it as well. But we can't answer whether this has 3 in it until we answer if this has 3 in it. So we separate this off into a smaller problem as well, and we want to answer whether 4 has 3 in it. And we can see here that since 4 is a single digit, we can tell immediately, or the computer is able to tell immediately whether it has 3 in it because 4 is not equal to 3. So this is like, we found something that kind of looks like one of the base cases we could work with, which is that if the number is less than 10 and it's not 3, then we know that this, the answer is false, or it has 3 or 4. So one base case is n is less than 10 and n is not equal to 3. So I'm just going to write that down for myself in the future. So since this is false, we return this back up here. And since this is false and this is false, the entire thing is going to be false. So that gets returned up here to this recursive call. Since checking whether or not 45 had 3 in it gave us the answer false. And we also checked 7, and that also gave us the answer false. This entire thing returns false. So that gets returned up to the original call that was made because we just checked 4, 5, 7. So let's say this part returned false. We checked whether 2 was 3, and that returned false. So the entire thing gives us false. Yeah, so this is one version of the problem, which is we pass in a number that doesn't have any 3s in it. But what if we have a number that does have a 3 in it? Let's say I pass in 4, 3, 1. So for this one, similar to what we did previously, we can only look at the last digit and ask, is this 3? And that's false. So since we know that part is false, we have to keep going. And now we have to ask, does 43 have a 3 in it? We look here at the last digit. That is true. So with this kind of function, as soon as we do see a 3, all we need to know is if there is any 3 in it at all. So as soon as we do see a 3, we can immediately return a true value. So that means if our input, if the last digit is equal to 3, then this is also a base case because we can immediately return true. If it's not equal to 3, then we have to keep going and call it with smaller versions of itself. Does that make sense? Okay. So to put this all together in the function, so this is a Boolean function, has 3, and it'll take in an input n. So the first base case that we were looking at is where we reach the first digit of the number. And that's when the input gets so small that we can check it immediately. So if the input is less than 10, if it's a single digit, and it's not 3, then that's a base case. And we can immediately return false. So if n is less than 10, and n is not equal to 3, then we return false. Otherwise, the second base case that we looked at was the case where the number did have a 3 in it. In that case, we can find it because when we look at the last digit, like if it was like the last digit of the original input, we could immediately return true. But if we also like cut off digits until we get to a 3, it's still the last digit that we're able to look at. So if n mod 10 is equal to 3, then we can immediately return true. Otherwise, what we want to do is if it's not the base case, then the version of the problem is too large for us to solve immediately. So we want to use the recursive call to cut it down to a smaller problem, and also tie it together with the rest of the problem. So if so at this point, so we can look here. If we checked that n mod 10 is equal to 3, and we return false, we return true, that means we left the function. So if we are here, that means n mod 10 was not equal to 3. Does that make sense so far? So if n mod 10 is not equal to 3 at this stage, if we reach this line, we know that n mod 10 is not equal to 3. So it's similar to what we were doing here, where we were checking the last function and checking if it's 3. So since we already did that check here, what we want to do here is return has 3 with a smaller version of the number, which is itself with the digits cut off. Usually if you're working with numbers, integers, and they're telling to like check the digits, the smaller version of the problem usually looks like itself, but with divide by 10, or with the last digit cut off. So that would be like, so this is how you implement this kind of function. So it's good to like start out with like an example of what kind of input you might get, and try to think about how you can cut it up into smaller chunks. With numbers, you want to cut it up by digits, basically. Yeah, any questions? Okay, if you don't have any questions, I might end the session. If you haven't filled out the feedback form, go ahead and do so. But also good luck on your finals. And thank you for coming. All right, have a good day, everyone.